Okay, so next bit, this is the base, this is the acid, this is the salt with no water being formed. So a lot of students, they always thought neutralization must form water. Well, it's still an acid-base neutralization reaction, but when you use ammonia, you don't get the water. Otherwise, you wouldn't be able to balance the equation at all, yeah? So this is a titration, it's a mole kind of question. If you are interested, you can check out my playlist on A-level chemistry under mole calculations. So a lot of the mole calculation in A-level, they relate to this kind of calculation you would have done in O-level as well. So the calculations are not different at all. Okay, other topics might be more advanced, but the calculations are not more advanced than this. All right. So if I compare the mole of sulfuric acid and ammonia, because this is what I want to find, this is what I have. So I will compare their mole ratio. Okay, I like to use fractions. First bit is from the balance equation. On the right side is the actual amount that reacted, okay, or actual amount that's formed. So the ammonia, I want the concentration of ammonia. That's in mole per dm cube. I must multiply by the volume of ammonia. This is in cm cube. So I need to convert that to dm cube by multiplying by 10 to the minus 3. The concentration of the sulfuric acid is 0.150 mole per dm cube. Again, the volume of sulfuric acid is in cm cube, so convert that to dm cube. This will give me the actual mole of NH3. This gives me the actual mole of H2SO4. This gives me the mole ratio based on the balance equation. Alright, so rearranging that, and I will get the concentration of NH3 in mole per dm cube, because this is already in dm cube. Alright. So I know it seems tedious, but it's really important that you rearrange your equation before you put things into your calculator, because it makes your life easy to check at the end of your paper. And also, even before you reach the end, you can double check your calculation here, okay, as well. So this is 4 significant figure. You need to make a decision, okay? Look at the data being given in the question. 1, 2, 3 significant figure. This is also 3 significant figure. This is also 3 significant figure. In an experiment, you cannot end up with more significant figure accuracy than what you started with. So here, I will convert it to 3 significant figure. But before that, I'll put down the actual value first before I round it up, just in case they decide to penalize me. I have shown them something which they can refer back to. Okay, they refer to examiner. Yeah. Next bit is a calculation question. So they say this is the cerium. So here we are dealing with solid. So therefore we need the AR there. So cerium is just that as an element. You have excess sulfuric acid, so not use. You do not use something which is an excess in mole calculation, yeah, because it's not completely used up. You want the maximum volume of hydrogen. So hydrogen exists as a molecule. It's a gas at room temperature and pressure, okay? Therefore, we need to talk about the molar volume of a gas. They give the answer in dm cube, so you need to be careful here. So I should probably use 24 dm cube per mole. Okay, if they give the answer in cm cube, then I can use 24,000 cm cube per mole, just so that, you know, it will be convenient. In fact, they did mention that in dm cube, yeah. So I can compare mole ratio. I compare hydrogen with cerium. Okay, it can be the other way around, because this will follow from your balance equation. First off, this is what I want to find. This is what I have. All right. I'm going to look at the balance equation now. 3 mole of hydrogen is formed from 2 mole of cerium. 3 mole of hydrogen is formed from 2 mole of cerium. Okay? That is from balance equation. Now this is from whatever value you know. Alright? This is mole of hydrogen. This is mole of hydrogen. What is the mole of hydrogen? The mole of hydrogen, because it's a gas, is going to be the volume of the hydrogen in dm cube divided by 24 dm cube per mole. So that will give you mole. That will give you mole. That is mole. So the unit carries through, yeah. Mole, mole, mole. Now this is cerium. I'm given the mass, so I have mass over the MR. In this case, it's just the AR because it's an element. Alright, so it's just divided by 140 there. Mass over MR, mole. Mole from the balance equation, mole. So technically the unit still carry throughout, yeah. Now I'm going to move this up there. I hope you can see the volume of H2 over 24 is 3 over 2 times 12.6 over 140. I can move up to 24. Remember the volume of H2 is in dm cube because I use 24 dm cube per mole. So that's going to give you 3.24 dm cube, and they did not specify to leave it to 2 or 3 or whatever, and plus this is the exact number, so you leave it as the exact number. Okay, what are the most confusing thing? People get this the other way around because they don't really know ratio. Okay, when you do the ratio thing, you need to be careful, yeah? As long as you could do it correct, it doesn't matter what method you use. But for me, I personally find that using more like this and stating it out clearly, is it a gas, is it a solid, is it a concentration? I think there was an earlier question that involved concentration, yeah, NaOH and HCl or something like that. It is still how you work out the mole. Is it concentration? Is it to do with mass? Is it to do with volume of a gas? All right. Next bit, they say this is the formula of cerium carbonate. They want you to work out the mass of cerium. So the mass of cerium, well, percentage mass of cerium. There's 2 cerium. Each cerium is 140. So that's 140. What is the MR? Oh, I think you better work it out separately. The MR is going to be 140 times 2 plus 3 of them, big bracket. 12 plus 16 times 3 oxygen. So you can get 140 times 2 plus 3 times 12 plus 16 times 3. Gonna get 460. Let me just double check because you know it's very easy to make a mistake here and there, and you want to be sure in a calculation. So that's 460 times 100%. So some people will forget that there are 2 cerium, so what they will get is okay, you get this, and then what value should I run it up to? That's the other thing you need to worry about, right? Okay, they didn't specify, and it's a lot of decimal place. Okay, you look at the molecular mass you work out. So these are actually 1, 2, 3. So this can be considered as 2 sig fig as well. So what you can do is you can interpret this as 3 significant figures, like 1, 2, and 3, or you can think about the 0 as having rounded up. So you can think about this as 2 sig fig as well. So it really depends on how you look at this. This can be 2 or 3 sig fig, meaning to say your accuracy can't be bigger than 2 or 3. Well, it can't be bigger than 3. Okay, so that is 4 sig fig there. So I can run it up to 60.9, that is 3 sig fig, that will be alright. If I run it up to 61, that will also be alright if I consider this as 2 sig fig. But this is not 4 sig fig, so I can't leave it at 4 sig fig, yeah? So that's the reason you run things up, yeah? Okay. Next bit, they want the ionic equation. So the idea is that you do not have spectator ions, yeah? So omit spectator ion. What do we need? The Na plus there is spectator ion. Okay, the Na plus there is spectator ion. So all sodium salts are soluble. That's how I know that it can dissociate to give me Na plus OH minus. It can dissociate to give me Na plus and C2H2CO or what am I gonna do here? COO2. Okay, and then there is going to be 2 minus. How do I get 2 minus? Because there's 2 Na. Okay, 2 times. There's also 2 times Na and 2 times OH minus. Alright, I'm gonna come back to it as what this actually means. When you look at fumaric acid, it has 2 carboxylic acid group, right? So when you look at it, it can form this salt. When carboxylic acid forms salt, it's gonna donate the H plus, right? So it's gonna give you that. So essentially that is C2, no, C4. Or maybe they write C2. They write C2H2 for C2H2, and then they write CO, what do they write? They write COO, right? COO twice. Okay, so there's going to be 2 minus. Of course, you can just work out the total number of carbon, the total hydrogen, the total oxygen, and just put a 2 minus. It's the same. But they decide to do the COO form to show that it's the carboxylate salt. So it's Na plus and Na plus. That's why overall it's 2 minus, okay? The most common mistake really, they would just put a minus charge there and you would have messed up totally. Okay, so this is actually an acid-base reaction. I can tell you it's an acid-base reaction because this is a carboxylic acid that is a base. And what I can tell you now is that I have just wasted my time because I should have realized it's an acid-base reaction to begin with. For every single acid plus base reaction, there is only one ionic equation. It is the ionic equation. There is no other ionic equation when you have acid plus base. It is H plus OH minus give you H2O. Whenever you have an acid, whenever you have a base, whenever they ask for ionic equation, straight away you can write this because this is the only one. You can try it, and then this is going to dissociate partially. They are still going to cancel each and every one out, except leaving you the H plus, here leaving you the OH minus, here leaving you the water. So this is the same as 2H plus 2OH minus give you 2 water. That is probably what you will get if you cancel everything out and waste your time, really. Okay, but this is the same as that because you can divide by 2 throughout. That's why I remember I just wasted my time. I should have realized acid, base. Actually, I did write down, I think, earlier. But anyway, I'm just showing you that the charge there is actually 2 minus because the Na plus, there are 2 of them, alright? So you got to be aware of it. Anyway, well, it's not time wasted. I just explained the whole thing to you. Okay, so now I'm going to do calculations. These are solution chemistry. So in solution chemistry, we talk about concentration times volume will give you mole. The quantity there is, the unit there is mole. The volume there has to be in dm cube because the concentration is in mole per dm cube. When you have per dm cube, it means divide by dm cube. So divide by dm cube times dm cube will give you mole. Alright, so what do I have? I have the acid. Now I can put NaOH on top first. So fumaric acid there. I've done mole ratio again. If you watch my other video, you will know that I'm a big fan of this method. It's not the only method, but it is my preferred method. I think I must have learned the other ratio method as well before, but over time I have perfected my own preferred ratio method, which is just basically using fractions, which I'm sure other people have done similarly before, but it's just putting it into very clear form. The ratio of the mole of one thing to the other, the use of the equal. You have come across this sign. Equal is a very powerful sign. Okay, it means equal. Okay, it doesn't mean anything else. It means equal. When you write equal, it means equal. So make sure that the units are actually equal. Make sure you are doing something that is equal rather than something which is not equal. Alright, that's the most simple message I can give you. As for the other way around, you can have mole of acid divided by mole of NaOH. It does not matter. As long as I have full complete information on the fumaric acid, I want to find out sodium hydroxide. So it can be either way around, does not matter. Have a look at the balance equation. So it says 2 mole of NaOH reacts with 1 mole of the acid. 2 mole of NaOH, I should probably have a smaller handwriting. 2 mole of NaOH reacts with 1 mole of the acid. Okay, there is mole and mole. What I'm going to do now is I'm going to put in the actual mole, which is still going to be reacting in this ratio. Okay, the actual mole of NaOH is the volume of NaOH. I'm going to do it in cm cube, okay, because they want the volume of NaOH in cm cube. So if that is in cm cube, I need to multiply by 10 to the minus 3. What does multiply by 10 to the minus 3 means? It means 1 over 10 to the 3. What does it mean? It means 1 over 1000. Okay, you gotta know how to key this in your calculator, yeah, just like this as well. Alright, so you divide by 10 to the, you times by 10 to the minus 3 to convert it to dm cube. You multiply by the concentration, which is 0.0500 mole per dm cube. Okay, volume in dm cube multiplied by concentration and mole per dm cube give you mole. This is mole of NaOH. This is mole of NaOH. This is mole of NaOH. Equal, equal. Alright, what is the mole of the acid then? convert that to dm cube by multiplying by 10 to the minus 3, and then multiply by mole per dm cube. In dm cube, multiply by mole per dm cube, it will give me mole of acid. It will give me mole of acid. I've done this over this based on this ratio. Okay, now I can move everything up and move everything around. So I hope you can see that it's 2 times 20.0 times 10 to the minus 3 times 0.0200. I'm going to skip one step. I'm going to move this all the way down there as well. So that will be 1 times 10 to the minus 3 times 0.0500. Work it out and you can get, well, I'm going to put this on my calculator. Well, I get 16. However, you see 16, that's what your calculator show you. All right. What do they want? 3 sig fig. Okay, so if you leave it as that, you have not read the question at all. Okay, always read the question, always go back to it and think about it. All right, even if they don't say 3 sig fig, you gotta know this is 2 liter, because have a look at the data. 1 2 3, there's 3 sig fig. 1 2 3, there's 3 sig fig. 1 2 3, there's 3 sig fig. Okay, so realistically speaking, based on the precision of the data, if they don't mention this, I would still need to leave it to 3 sig fig, which will be 16.0. Why 0.0? Because they don't show on the calculator, that means it's 0.0. Okay, because now you will have 1 2 3 significant figure, and it will be a volume in cm cube, because they already have cm cube there, and I use it in cm cube. That's why I multiply by 10 to the minus 3 there. Okay, cool.